Hi, Jay. Thanks for joining. How are you today?
I'm doing well. How are you doing?
Yeah, I'm good. I'm good, thank you. So, do you want to say something for future generations of people who'd be watching this video?
Yeah, absolutely. This is definitely one of the less covered topics when it comes to interviews in general. So I'm hoping this system design, interview will help kind of give some clarity to some other developers as they're, working through their way up the process and growing in their careers for sure.
Yeah, totally makes sense. All right, let's start. So I just sent you a link to the Excalibur for you to join.
Perfect. Go ahead and open that.
All right, can you see my mockup?
Yep, I can see it.
All right, so the problem statement, we need to design a messenger app. So today we're specifically talking about iOS system design, but it's also applicable for Android engineers. We need to have two screens, a chat list and a specific chat. So on a chat list, we need to show a list of chats with your friends. There we need to show an avatar, a small image of a person, the name, and the excerpt from the last message of that person and the timestamp of that message. So you can see that the chats are sorted. So basically the last chat is on the top, and then you have like others, and then you have the ability to click on a specific chat and open a chat with that person, and there you can see messages, timestamp, the text obviously, and it's also possible to send images and files in this application as well. And also let's cover like check marks for delivered status. Since they're not on the mockup, I can write a check mark. So like here should be like a small check mark.
Mhm.
All right. Yeah, that's it from my side. You can start.
Perfect. Awesome. We'll start with the chat list, or actually, yeah, we'll start with the chat list screen for now. Obviously, I think those requirements are pretty straightforward. We want to have a image here. Do we need to have, obviously the thumbnail might be a lower resolution image just for space saving constraints. Should we also have a high res image as well to view?
Yeah, so we want the user to have an option to click on the image and make it see the whole picture.
Perfect. So I'll note down high res and low res images for profile. Perfect. For the chat screen specifically, do we need to also show any type of typing indicators similar to like iMessage where we're showing the status of, a user is typing or not typing?
Let's skip this for now. Yeah,
Okay.
if we have time in the end, maybe not now.
Okay. Perfect. How important is latency? Do we need to show text messages like immediately, or should we have any kind of delay? Is that okay?
We want to show them as fast as possible. So yeah,
Cool. Messages in
absolutely.
real time. Perfect. And then I think, are we going to support any push notifications with this MVP, or should we just focus on internal the app only?
Let's focus only on the internal part of the
Okay.
app.
No PN4 MVP. Perfect. Okay, cool. Let's see. Yeah, I think that answers most of the questions. Are we going to have any offline mode for this as well? Should the user be able to view the application offline, like messages, files, and chats?
Yeah.
Perfect. Perfect. We want offline functionality, so probably want to implement some form of caching. And then let's see, for the chats, are the chats only one way, like user to user, or should we consider like group chats as well?
Let's consider only user-to-user chats for now.
Okay. No group chats. Perfect. Yeah, I think that's all of my clarifying questions. So I'll move those over here to the side for now so we can define our functional, non-functional requirements for the first step. So let's outline some of our functional requirements. So yeah, we want to send and receive messages, obviously. Let's see, we're also going to want to, let's see, we said files as well. So we want to send/receive files and images. We want real, that's going to be probably more of our non-functional requirements. Support one-to-one chats, no groups. User can view chats offline. And then let's see, we're not doing any push notifications. We want the caching, group chats. We want to be able to support low and high res images for profile pictures. I think that sums up most of our functional requirements. For our non-functional now, we will non-functional requirements, and we'll do, we want a few things here. So we want to, we could probably put the offline mode here instead of in the functional requirements. So we'll say offline support. We want to have real-time updates.
Yeah, before we move forward, I just want to mention that we also want to send messages in the offline mode, basically.
Mm-hmm. Okay, cool. I'll make sure to note that as well. Offline support, send messages. Perfect. Real-time updates, and then we want to obviously have some optimizations. Optimize for things like lower network speeds, low connectivity. Users are traveling a lot and going to different places, so it'll make sure we're optimizing our network calls for that as well, in battery usage constraints. So optimize for
let's do that.
Slower
Makes sense.
network and battery. Perfect. So I think that's going to cover our non-functional and functional for this. I'll go ahead and remove our questions for now, and I will place this over here to the left so it's in line. Does that fulfill the constraints of this design for these functional non-functional requirements, or should I move anything around?
Yeah, I think so. Yeah, we can come back later if we want to add some additional functionality. Yeah.
Perfect. Awesome. So now that we have our functional non-functional requirements outlined, I think the next step is going to be to outline our data models, the important data models we'll need for the application. So I'll go ahead and put these down here on the side. We'll say data models, and we'll start outlining our data models. So obviously the first things first, we're looking at the chat list, is we're going to need a chat object that's going to contain reference to the chat itself as like a unique identifier, but also a snippet or preview that can be displayed on the chat list. We can use that same data model to both reference the chats later as far as updates and pulling them, but also showing the previews. So we'll have our chat object here, and we'll identify some of the key properties we need for this. So we'll say, for starters, we want like an ID. So we'll have a chat ID, which is just going to be a unique identifier. We'll also have a user's identifier most likely here. Typically, I know we mentioned we don't want to support group chats for now. I'm still going to make this an array in case in future iterations we decide to support group chats. It's just simpler. So we'll just make this an array for now that it consists of users. Obviously, for the MVP, we're just supporting one user. But in the future, obviously, we might want to expand to group chat, so we can have this there in the future when we want it. Obviously, we're going to have a status of the chat. We want to know, like, from this chat screen, I'm assuming we want to know if like the messages have been read or not, similar to how we have like indicators on like a mail screen, or even your existing app right now. It'll show you if you've read this chat yet or not. So we'll have a status, which will just be read versus unread. We'll have like a preview as well, most likely. So we'll want to, obviously have the most recent text display so you can see a preview on the screen. So we'll just have a quick preview here, which will display a string for the last message received. So I'll just put that here as a string, and we'll put in parentheses last message sent or received. And then we'll want a timestamp of the last activity for this chat. So we'll say last activity, and we'll make this like a timestamp that will identify. One, we can use this in our our cell view model to display the time at the top. but we can also use the last activity, from the server side for sorting and things of that nature, for our list. So that will cover that should cover the chat list. It covers all the key requirements. So for the images, as far as the image preview, we'll use this user object, and we'll store the image for that user in here and use that for our chat image. Obviously, the user you're sending the messages to. So we'll store that image there, so we don't need that on the chat object itself. We have a status, we have the preview, and the last activity. So I think that covers the chat model. Next, we'll want to do obviously a user object. So what we'll do is we will say user, and we're going to create a user object similar. So we'll create the user, which will have like a user ID. And then we'll also have we'll have some various different information, like we want to have a user image or thumbnail. So we'll say user, let's say, we can just say image, maybe like a thumbnail for this one. And then we'll have a image full res as well. And these are both just going to be URLs. We're obviously not going to store the image in the user object itself. We'll store reference to it, and we'll create a service later to retrieve, cache, and place those images within the view accordingly. So we'll note that this is a image.
Sounds good. Yeah.
Image URL there, and an image URL here. We don't need the preview. Oops, we don't need the preview for that. So we'll have an image, user ID, user thumbnail. We obviously want the name of the user as well. So we'll do user, maybe like we'll just say first name, and then we'll have last name just to differentiate last name, and then we'll also have we can have this similar identifier. We'll say last active, and we're going to use this as well. Speaking of last active, I didn't clarify this in the functional non-functional requirements. Do we want to show whenever users were like last online or like last seen or anything like that, or no?
Yeah, let's show just if the user is online or not. Basically, like a green circle for online users. So
okay, perfect.
Yeah.
Okay, so for the user, I guess we don't need this last active. Then we're going to only show when actually, let's see. Yeah, we'll do a is active, and we'll just have this be a Boolean true or false. For that, true, false, for is active, and that should be enough to cover the user. I'm gonna add that to our functional requirements too. We'll say show user is online or not. Perfect. And then the last thing that I'm thinking that we're most likely going to need is the message object. So I'm going to place that down here. We'll have a object for that.
Yeah, before we move forward, I just want to just want to add a small note for the is active field for user is like changing really frequently, and I don't think that this specific data model would be also like updated frequently because yeah. So what do you think? Do we want to handle it like separately, add some sort of real-time updates for online status for a user as well? Or, I mean, we can skip it for now. I just wanted to mention here that this is also like data that frequently changes.
Yeah, absolutely. We have kind of two different approaches, I think, for this. Obviously, for something like a live chat application for real-time updates, we're probably going to use a WebSocket to receive those updates. So we can probably get away with whenever, from a server-side perspective, we can have an event that's sent when the other user is also connected to that WebSocket and show live status then versus not. So we can handle that through the WebSocket, or we can handle that through the user object. I'm guessing for this, since we only want to show it on the chat page, you're right. We could probably remove this is active on here and then handle that via just some logic to determine WebSocket connection on both sides. We'll have the WebSocket send us whenever the other user is connected or online on their side.
Yeah, makes sense. Makes sense. Thank you.
Yeah. The only caveat to that I would say is in the event, like let's say a user is already online or something, and then I connect to the WebSocket, I would like to know that they're also online. So either we can have WebSocket event that says, that sends the initial information about the user, or we can pass that in as part of the initial like request for that page as well, and update the user object accordingly. So
Yeah,
we'll
probably that would be handy, yeah, to get the
yeah. So
data initially and then
yeah,
update it.
yeah. So maybe we'll remove it from the user object, but we will make sure to consider that as part of our API request whenever we get the information from loading the chats, whether or not the user is online. We establish that WebSocket connections
Yeah.
probably best. Perfect. So for the message, we'll want obviously I don't think we need any unique identifiers for messages in particular, unless we're going to support anything in the future, like liking a message or deleting a message or things like that. We didn't go over that in our function requirements, so I'll admit that for now. But that's going to kind of determine if we need a unique identifier for
I think,
each.
yeah, in the future we may possibly want to extend the message to be like edited or deleted.
Yeah, for sure.
Yeah. And
Perfect.
also
So we'll add that ID there.
for retrieval mechanism in a situation when, let's say, a message is lost somehow. Yeah, probably it could be useful to have an ID to understand the conflict.
Yeah, absolutely. Yeah, so we'll add the message ID. We want to add any attachments that are sent as well. So we'll have an here, and we'll make this just a list of attachment objects. I say objects only because we're going to support various types of metadata. So we could have like files, we could have images, we could have videos and other different types of attachments. So I want to have an attachment object just to be able to identify the type of attachment with the links, so we can handle the changes on mobile accordingly. So otherwise, if it was just images or something consistent, we could use just some URLs here. But because we have some varying types of data, we'll make sure to include a attachment object here inside of here. And then we'll want a status is fine. We want to know if a specific message has been read or unread. We'll also want to know a timestamp for, we'll want a timestamp for both when a message was received as well as when a message was read. So we'll say message, and these could be null as well, considering a message could also have not been read. So we'll say message received, or message received, which is a timestamp. And we'll also have a message sent as well. I think I missed that in the initial one. We'll say message sent with a timestamp, message received, and then message read. And honestly, considering we're having this message read timestamp as well, and that fact that it could be nullable, we could also just remove this read unread status, because we can, if we have a message read timestamp, we'll use it. If not, the message hasn't been read. We have that approach as well.
Yeah, what about sorry to interrupt you, what about the requirements to have the option to send messages in the offline mode? Do we need to update this model to somehow help us support this feature? What do you think?
Yeah, absolutely. So my initial impression is similar to how we do the read and the sent. We have multiple different options here for this. So what we'll do typically in like an offline scenario where we send a message is we'll create like a queue in the background for whenever a message hasn't been sent. This will be sort of like the database in case if it's a long time period where you're offline, we'll want to save all of those messages that haven't been sent yet. So in theory, we could either have a direct flag for something like has been if it's actually been sent or not with a Boolean, or we can again use the nullable fact of the timestamp for like this message hasn't been sent yet because there's no timestamp for sent. Maybe for a more straightforward approach, we can just go ahead and add a Boolean for message sent and message sent time. And then we'd have message sent and then just make this a Boolean to make it easier on us to have an actual direct flag for that. But we have various different options, I think, depending on our needs. So we'll go with the Boolean approach for now to make that
yeah, makes sense.
So we have a sent time, we'll have a received time, and we'll have a message read time. And then we'll also do message sent, and then we'll do message read. And then honestly, let's see, we're obviously in a message object, so I know naming's not important right now, but we can
Mhm.
move the message on this
Okay,
because we're
that's fine.
subject. So we'll say red is the boolean, which is cool. So I think that covers, let's see, we have the message ID, we have the attachments, we have the time it was sent, time it was received, time it was read, the sent and read booleans as well. And I think that should be the three main objects we're going to need for
Yeah, do we need a
this.
text? Do we need a text field?
Oh, of course. Of course, that's the the most obvious thing. We'll have the
Yeah.
message text. So we'll have text and just a string of text inside of it.
Yeah. Okay, cool. Mm-hmm.
Perfect. So that should cover all the cases for now for meeting our functional requirements. We can send and receive messages. We can send and receive files. We have chats in our groups, offline support, low res images, and user offline. So that's good.
I think you wanted an object for attachments, like a separate model for that.
Yeah, we can write that out. It's going to only have two properties in it, but we can go ahead and define that as well, just for formality, attachment, object, and we'll just make this have a type, which will just be an enum of, whatever supported file types we have. So it could be, image, video, PDF, etc. And then we'll have the URL to that attachment, which will just be an endpoint to attach. So yeah, that should cover our attachment. Pretty simple. I just want to make sure we can dynamically respond on the UI according to whatever attachment being sent. We can actually differentiate between the two.
Let's say our attachment is cached on disk. Do we want to cache them on disk?
Do you want to cache what on disk?
Attachments, for example, images or files for an offline support.
Yeah, absolutely. And I'll kind of get into that a little bit more probably in our high-level design. But the goal is that we would essentially have a service that manages our local disk cache. And so what's going to happen is we'll have a coordinator that makes the request, and the coordinator is going to do two things. It's going to detect, hey, do we have this attachment URL? Because that's what we're going to identify each file as. Do we have this URL already cached? Is there something in the cache for this? Then we return that object. If there's not something in the cache, then we go and make that fetching, but that'll be handled through a coordinator. So we can save the attachment object into our database, but then we'll have a separate caching system for our files that'll be retrieved depending on if we have that. So that's perfect. And then we'll jump into, now I have the data models defined for all the functional requirements. We can jump into the endpoints. So I'm going to go ahead and make that section over here. API, do a REST API for this, API end, and outline some of our REST API endpoints. So obviously for the chat, I'm thinking we have a three API call pattern, because we want to consider things like the slower networks and the offline support. So what I'm thinking we do for the REST endpoints, specifically for the chat list, is we have three endpoints. We have the scenario where a user initially loads an application from scratch. They just download the app or something along those lines. And essentially we want to fetch all of the available chat list, but we also want to constrain it. We don't want to make a network call and have a response of like 10,000 chats or something obnoxious. So what we'll do is we'll have a REST endpoint to get the chat, and we'll say all. And essentially the constraint of this get all endpoint is that we want to make sure we only return enough chats to just present something to the user as quick as possible. So we might say, let's limit our first call to like 10 or 15 chats to preserve our API calls. So this is going to return, let's say 15 chats for now, 15 most recent chats. And then we also want to return let's see, for this one we want, I guess just 15 chats is fine. So we'll have a chat that returns all of the chats, the most recent 15. And then because we're doing that, we'll also need some form of pagination. So we'll also have a get chat all, and then we'll have like after, and we can have a timestamp after that. So we want to, as we're scrolling through, or we get to the 15th chat, we want to load the next set to be considerate of API usage. So we'll have an endpoint for that. So that's going to load based off of the last chat's timestamp. So the server can know which chat to return. So we'll say return, next 15 chats after timestamp, which will be relevant to, if this Jamie is the last item, it'll have a timestamp associated with it, and we'll receive the chats from that date forward. And then lastly, just to
sorry to interrupt you, I have a question
Yeah.
here. So let's say we want in the future change the batch, let's say from 15 chats to 25. How we would do that?
Yeah, so from the app perspective, it's not going to change anything. So we're using the last chat as the
Okay.
indicator of what to fetch next. So if we do the last 15 chats or last 20 chats, it's going to take the last timestamp of the chat in our list, and it's going to fetch after that date. So whether we have 20 chats in the list or 40 chats in the list, dynamically we're going to respond to that last timestamp.
Yeah, so the number of chats is it's fixed on the backend, basically hard coded.
Correct. Yeah, we'll do backend, and again, the backend should calculate, and we can have either hard coded or even device specific. We just want to make sure we can show users data as quickly as possible for a really responsive interface. So we want to make sure they're not spending 60 seconds loading chats because we have 1,000 of them. We only want to return the most pertinent information up top. And then lastly, for the chats, I also want to have an endpoint for. I want to have a endpoint for delta changes. It's going to be a delta endpoint. So essentially what we want to do is for the third use case, which is essentially I update the application, on a relatively frequent basis or even infrequent basis, I only want to fetch the new data. I don't want to fetch anything we already have in cache. We're going with this like offline first approach. So what I'm thinking is we can have with all of these requests that were being sent, a sequence ID or something similar. And essentially what we want to do is we want to update the chats with information after that sequence. So that way we're only fetching new information and not old information repetitively. That fills the constraint of, being our non-functional requirements of optimizing for slower networks, returning less data, but it's also less intensive on the battery to have to process large lists. We're only processing new information.
So I just want to understand what sort of deltas do you want to get. So what sort of specific fields do you want to get, and what fields do you want to cache somehow?
Yeah, absolutely. So the goal is that we're going to cache the entire chat object for again. So when the user opens the application, they have a list of chats immediately. There's no loading time. The goal would be that as far as returning new information, that I would want to return a new preview, depending upon if a preview came that was offline that I didn't receive or I wasn't online, and I'd also want to update the timestamp for when the last activity happened, because for instance, if I go offline for an hour and I receive a message in that time frame, the timestamp's going to update as well. So essentially what we would do is we would just send an abbreviated list of updates and handle and process on the mobile side. That way we're not sending the entire list of chat objects every single time. It's just another procedure we can do to improve the user experience and loading times. We can make it even more lightweight and even faster by just sending the updated information rather than an entire list. Now, to your point, we have a very short list and the data is obviously super lightweight. So we could probably get away with sending the chat object as a whole, but then we'd have to do something along the lines of like purging our local our local cache for all of the, cache chats and things of that nature and handle the merge conflicts, where I think we could probably get away with something better with just sending the updates from a Delta endpoint. So we have obviously two different approaches. There's trade-offs with each, but I think for, max efficiency and simplicity, we could probably get away with a Delta as well.
Okay, makes sense. Yeah.
So we'll say Delta. ID. So that covers the.
Sorry to interrupt you again. Another question. So how would you calculate the delta? So I can clearly see you're passing a sequence ID here, but what's a sequence ID and where do you get it? Because I don't see in the chat object, in the chat data model, I don't have a sequence ID or anything like that.
Yeah, absolutely. So the goal would be that we would get a sequence ID after every, every call from these above ones. So this get chat all request. When we make that initial load, we'll get a sequence ID and it'll perpetually update from there. So like, let's say on the initial load, the user gets this list of these four items, right? Whenever we make that request, we're going to store and cache a sequence ID specifically related to the chat list. It's not on a object level. So it won't be in each individual chat. It'll be more of an ID that's stored separately related to specifically the chat list. That'll be stored separately outside of it. And then we don't need a delta for the pagination, obviously, because we've already loaded the first set of data. So the goal will be that like after I load this set of data, these 4 items, let's say I log offline for an hour and then we have Max who texted me afterwards. The idea would be that if Max is the only person that texted me, I would just get a result from this delta endpoint of the newest message, the preview, and the timestamp. And then my feed could dynamically update according to the new timestamp and that new preview versus having to go and upload everything and refresh all of the view models for each individual. So.
Yeah, interesting. Yeah, I think I would personally prefer to store the sequence ID together with the data, meaning somehow with the chat, or create a chat list object additionally to store it there, because I just don't like storing some IDs. But it works as well. Yeah, absolutely.
Yeah, absolutely. I think to your point, that's probably where we would end up going is creating a list of chats. And dynamically having that sequence ID associated with that list versus having, because we just don't need it on an object per object basis. We don't need it on each chat. We don't need it on each message. We would need it as the entire structure. So yeah, putting it in a list with a identifier would probably be the best approach for keeping that clean. So yeah,
makes sense. Yeah.
Yeah. Perfect. So then we're going to do a similar set of endpoints for the chat specifically. Obviously, we're not sending the entire list of chats associated with each chat object. We're only going to load the chats based off of when we tap on them. So obviously there's going to be a multi-layer step here too. We're going to obviously load the most recent chats from cache that we have to show something to the user. But while we're doing that, we're going to be doing a couple different things too. We're going to get the most recent list of chats that have come while we were offline, and that'll be an API request. And then we'll also want to, and this is an input I'm going to add as well, is we'll want to establish a WebSocket connection to receive those updates on the chat in real time going forward after we've caught up to the most recent chats. So we'll want to do a endpoint similar to this, where we will get chat. We'll pass in our chat ID here, and then we'll say all, which is going to return all the chats. Again, in a similar scenario where I haven't loaded any chats, I have nothing cached. We want to load all of the most recent chats. Probably want to return more than 15 for this one because of the fact that I'd like to see several messages and be able to go through before having to keep making API calls. So we might improve this to something like 50, since the messages are, like you said, lightweight as well.
Here it should be return 50 most recent messages, right?
Messages, yes sir. Perfect. 50 most recent messages, and then we'll want to do a same thing. We'll also want to have some pagination for this as well. All, and we'll do before for this one, and we'll do timestamp before. Perfect. We'll have a get chat ID returns next 50 messages. Cool. We'll do some pagination. And then I don't think we necessarily need, we can go with the Delta approach again for this as well. Like when we load a chat, we only want to know what's changed. Obviously, we don't want to get messages that we don't want to redo messages that we already have. So we'll do a final endpoint for the Delta to just receive anything that's happened after our last sequence ID that we store. So chat, we'll do all, and then we'll do.
Do we need a sequence ID here, or we can use a message ID?
Oh, we could do a sequence ID or message ID. I think because we have messages coming at specific dates and it's linear as far as a time perspective, we could probably either use a message ID. We could probably use a timestamp, honestly, too. All messages after a certain timestamp, and that might be probably a better. So we'll have let's change that. We'll do all messages after timestamp, and then that way we don't need the sequence ID for this. So we have a messages before and messages after. Return. We'll say return all recent messages after given or provided timestamp. And that will allow us to get the most recent changes versus having to refresh all the other ones. So that works. And then we'll also probably need one more endpoint to, well, we need two more, but we'll need one more to actually handle the, we'll need an endpoint to retrieve the images from our, or actually, no, we'll have the URLs from there. We'll be able to do that differently. Sorry. We'll need an endpoint for the WebSocket. We'll need a WebSocket to handle all of the live changes. So we'll just say this is our WebSocket. And it's going to be for chat ID. And what we'll do is essentially in our application, we'll subscribe to changes from our WebSocket and handle the new updates by updating our local cache as we receive our WebSocket changes. And we'll also be able to post messages to this endpoint as well. Now we also have to consider the offline mode that we refer to. So whenever I, send a message and I can't establish that connection to a WebSocket, we're going to cache that message. And then I would probably say we'd want to have a direct REST API endpoint because we're going to handle that in the background. So essentially in my mind, the way that we would flow is I log into my chat, I would send a message, I'm offline, so I can't send that message. We'd notify the user, that would go into a queue. And then whenever I reestablish connection in a background thread or something similar, I want to make sure that I send that update immediately versus waiting for a user to actually go in and connect to a WebSocket. So I might want to have a post as well for sending a chat whenever we encounter that scenario of like sending it from a background thread or offline as well. So I'll add that here as well. Want you post?
Yeah, I think it's a really good decision. Yeah, to have a post for sending messages as well, because sometimes people use only post HTTP for sending messages and WebSockets only for reading messages. So yeah, why do you think that is? Actually.
So when you use a WebSocket, you have no idea about you can't do any logic whenever something fails. So as far as like retry logic or things of that nature, when you do a post request, you can guarantee that something is delivered. Versus a WebSocket, you don't really have those same the same ability to at a high level, diagnose whenever there's an issue or a problem with what's being sent. So by having that post endpoint, we can have our own logic. Like you mentioned, when we have low internet connection or something, if I make a request and it fails, the WebSocket, the message data is gone. Versus if I do a post request, I'm able to in real time see, if this message is failed or something similar, and I can have some custom retry logic, or even like we said, if the network connection sucks, we can do a, store it in the cache till later, and then establish that data or send that data when we have a more established connection.
Yeah, makes sense. Totally.
So on this one, we want to say we're going to send a message object send a message object is probably fine for that one. Post chat ID message, and we'll receive a successful or failed message on that. That works. And then, if something fails for some reason in that post endpoint, we can update the sent flag to false, and then we can query it later from our background manager that handles the syncing of messages from the offline state. So I think that covers most of the, I think that covers all of the endpoints. We can get a chat, we can get chats after, we can paginate, we can get the delta changes for all of our chats. We can also do the chat ID we can get for all of the chats, most recent 50, it's before timestamp and after timestamp. We can post a chat in WebSocket. So yeah, I think that works for our REST API endpoints.
Do you want to write every event for the WebSockets, or we can skip it because just for the sake of time, it may take a lot of time?
I'm thinking for the sake of time, we probably just skip that for now. Relatively straightforward for our approach. Obviously, we're going to be doing things, receiving a message dot receive message dot sent to that two-way channel on the WebSocket. And then in the future, we can also use WebSocket for things like typing indicators, etc. But we don't support those events right now, so I think we can skip that one.
But just for the audience to know, how do you actually do that? So, if you want to specify, like, let's say one event for WebSockets, let's say a read or send event.
Yeah, if I was doing it, I would probably create a generic class that supports
Mm-hmm.
a array of types of events. So I'd have one event be message dot sent.
Mm-hmm.
I would do one being message dot received, or one is message dot started typing or something. Use like an enum to switch between those different types, and then I would filter on the client itself to be able to know how to handle and respond to those specific
Yeah,
changes.
makes sense. Okay, thank you.
Yeah, absolutely. So yeah, that's our API endpoints. We've verified that they cover our functional requirements and our non-functional requirements, and now we can go through and actually start with the high-level design. So obviously, we're going to have two screens for this high-level design. We're going to have a screen for our let's say our chat list view, and we're going to also have a chat. I want to call it a chat thread, maybe. Let's say chat thread. I'll make this a little bigger for you. That way we can, yeah, perfect. Perfect. Chat list view, chat thread view. I'm going to go with a Swift UI approach for this for a couple reasons. One being we're doing large sets and streams of data. So data is going to be constantly flowing through our WebSockets and things of that nature. And with Swift, we can have a really reactive chain of events from our API client all the way through to our view and respond to those changes dynamically and update our view to respond to our view model changes. So I think for this kind of layout in this application, it's going to work really well for us. And then we're going to do this modularly and clean with like a MVVM approach. So essentially, we're going to delegate all of our view logic in our views. We're going to have all of our business logic in our view models and coordinators and repositories, and separate everything out so we can have a really clean model for both dependency injection in the future, high testability and modularity, so we can follow really solid coding principles. So I'm going to start by doing our view model here. So we'll have our chat list view model, and we'll do the chat list first. So we'll say chat list view model is going to go here. And then we're also going to have a chat thread view model. And that's going to go here. And then essentially what I'm thinking of is, since we were having multiple streams of data, to introduce a coordinator. Essentially what I'm going to do is the view model shouldn't have to worry about fetching data from various different sources, being like our local cache and our API endpoints and our WebSockets. So I'm thinking of using a coordinator to kind of orchestrate the connection between all of our different data sources and where our data is fetched from, to return to our view model just a simple function and a simple publisher that we can use to update our view and kind of abstract out that logic to a coordinator. So what I'm going to do is I'm going to draw here. It's going to be our, it's going to be our chat list coordinator. And essentially what that's going to do is what I said before. We're going to do chat list coordinator. And then this chat list coordinator is basically just going to abstract out the logic for fetching the data from the API, fetching the data from our local cache, and various different services. So I'll have, like, for our chat coordinator, we might have a, let's just say we'll have our, we'll start with our local DB, and then we'll also have our API client as well. And essentially what the coordinator is going to do is we want to essentially, like I said, abstract out the local DB and the API client. So we'll have our local DB, our WebSocket as well, and then our API client also. So let's see. Actually, we'll probably abstract that out. Let's do API client, and then we'll do our WebSocket. And essentially what I'm going to do here is have our API client, our WebSocket, and then we'll also have our repository, which is going to be responsible for managing the data locally. So what's going to happen is the chat list coordinator is going to come, and it's going to determine whether or not I need to fetch data from my local, or I need to fetch data from my API, and also coordinate the updates to the local database. So essentially, we're going to return, obviously, on our Combine thread for our view model. We're going to turn the local data first, And then depending upon the response from the API client, we'll update the local data if we need to and return that to the view through our publisher subscriber paradigm that we use with Combine. So I'm going to draw an arrow here for this. Oops. Our API client. And then, oops, let's make this. I think our arrows are weird today. Let's see, stroke style. There it is, cool. Perfect. And then we'll have our WebSocket as well. Perfect. And then we're going to have a repository here that's going to handle all of our local database related things. So we'll have a chat list repository, and this is going to handle all of our local data management. So we're going to have two local data sources, obviously, for our objects and relational database. We're going to use a client like Core Data or Realm. Typically, I go with Realm for applications that could have any kind of cross-platform functionality. If we want to expand to Android in the future, Realm is good because you can share schemas between platforms. If we're just making this iOS focused, we can use something like Core Database. For the purposes of this, I'm going to use a Realm database for our object database, and we'll use the disk storage for any of our files and images that we want to cache as well. So I'm going to put these out here as well. We're going to have our we'll have our local data storage, and we'll have our file storage, and we'll also have our local DB. And that's going to be, for the purposes of this, we'll make this Realm, but we can use Core Data as well if we need to, depending on the requirements. So the repository is going to go, and it's going to fetch data from our file storage. And it's also going to have the ability to fetch data from our local Realm DB, and then our coordinator is also going to be able to coordinate between these two. So essentially the idea, like I said before, now that we can visualize it, is that the chat list coordinator is going to handle the coordination between all these different services. So local, our API client, and WebSocket. So at a high level, if we were doing something like retrieving our first set of chats, we would go to our coordinator, we would check our local repository first and return that to our view model so we can update the user with immediate data. And then we would also, handle the calls to the API client and subscribing to the WebSocket. So the API client would be for fetching the most recent data that we weren't online and didn't have the WebSocket connection for. And then we'll use the WebSocket subscription to handle the continuous stream of events that will flow to the view model eventually as well. So the schema is going to be similar for the chat thread as well, specifically for, the WebSockets, things of that nature. So we'll have our chat thread coordinator, and it's going to follow a very similar data flow. So we'll have our coordinator go to our API client to fetch any updates that we missed while we were offline. We'll have it subscribe to updates from our WebSocket whenever we're ready, and then we'll also be able to have a repository similar to this where we can fetch and manage data from offline. So we want to retrieve a file in chat, an image from the chat, or things of that nature. We'll do that through here as well from our local storage. And if we don't have that local storage, obviously we'll use the API client to fetch it and save it to our local repository. So we'll do chat thread repo, and then we'll do the same thing as far as the architecture goes. We'll do this to this to this, and then this repo will manage our file storage and our local realm DB. So let's see. Chat's gonna be here. It's gonna be here, and then we'll just do these last two. And then I also want to make a note for. I want to make a note as well for our design. I want to put up here just so we can make sure to mention it. We also want to account for our dependency injection. I'm not going to draw the arrows for this one, but the way we're abstracting everything out, like I mentioned before, is important for testing and modularity and separation of concerns. So what we'll be able to do is we'll be able to actually inject dependencies to our coordinator and to our view model, so we can make our modules testable. There's a variety of reasons that we do this. If you want me to go into more detail on that, I can, but I'm going to put this up here for the time being. And then one other thing I want to add to...
So sorry to interrupt. While we're here, just could you explain how you built a dependency graph? So how do you let's say, provide a view model to the view, um, how does it happen?
Yeah, so there's a couple of different ways. It's going to kind of depend on your use case and your company size and how you want to kind of manage that. But the most simple way is to do it through our initializers. So we can
Mm.
initialize our classes with through our init method. We can have a protocol that mocks out our chat list view model, for instance, and we can inject anything that conforms to that protocol, which would be like a chat list view model protocol. We can inject anything that conforms that to our list view. And the importance of that is that we can substitute sample methods that our view can respond to for testing. And so that's the simplest way. We can do that for all of our list view model, our coordinator, et cetera, through the initializer. You can also use something more complex, like I think it's Swinject is one of the popular modules where you can define your dependencies prior to runtime, and then at runtime it will inject them according to some predefined constraints. So depending on if you're in production or if you're in QA or various different environments, you can inject different dependencies to perform differently or fetch different data according to different configurations or project runtimes. And then the last way, obviously, is through a similar method using like Swinject or something, but you can do it through like feature flag configurations. So if you want to enable or disable a certain feature or a certain data flow through your various network configuration is set up as well. So.
Okay. Yeah, makes sense. All right.
And then the last thing I would probably want to add on here too, that I like to integrate into applications that have various different states is a state manager. And the reason I do this is because I like to ensure consistency across our application for how we handle states. A lot of times you get in situations where you have various different views and you might handle loading differently or you might handle data differently. By using a state manager, we can ensure consistency across our application for application states. We can define, loading, success, failed, error, etc., and have our views dynamically respond to our preset state managers. So we don't have to worry about inconsistencies across our applications when it comes to various different view states like fetching chats or loading new chats or things of that nature.
Yeah, I would love to know more about this state manager. Could you give me an example? What sort of state can it hold?
Yeah, so the state manager, we would have various different view states. Obviously, for like a list, we're fetching data, either a feed or a chat. The basic states we'd have are like loading, if there was an error loading data, and then we'd also have like a success or even an empty state would be like kind of the key, the key four states you would have. And so essentially what we can do is we can have a state manager responsible for our different views. So like for instance, the feed, for instance, or the not the feed, the chat list, for instance. We would have a state manager which would conform to not conform. It would contain an enum of those different states. And also respond to data changes for those states. So in our enum, we would have loading, we'd have success, but the success would have a generic type of data dependent upon what we wanted to load. And so essentially what we can do is we can have a state manager inside of our view model. And whenever our state changes, we obviously can dynamically respond to those changes on the view in a controlled and consistent manager in a consistent way across the application.
Yeah, interesting. So the state manager should know about the API client because you're saying that in case we're doing a request or getting an error, we should get that data from the network client or API client or WebSockets, right?
Correct. So how it would look is in our view model, whenever
Uh-huh.
we make a request to our chat list portal, let's do an example of fetching the
Mm-hmm.
initial list of chats. I would have my function to fetch chats from the coordinator. And basically, whenever I get that data, so when I start loading the data, I would say state manager dot is loading, right? State manager dot is loading when I
Mm-hmm.
start requesting that data. And then when I get the data, I would say state manager dot success and then pass the data as part of the enum into the state manager. And the
Hmm.
chat list will be able to unwrap that data from the enum and respond to it dynamically according to the state inside of the state manager.
So you want to pass data back from coordinator to the view model through the state manager.
Correct. So the view model
Hmm.
will instantiate the data into the state manager, which is going to be the source of truth for the view, and then the view will respond to that data accordingly.
Interesting. Do you want to use just one state manager for both chat list and chat thread?
No, what we would do is we would instantiate a state manager on each view model. The
Mm.
state manager would just be a state manager would be like a would be allow for consistent design across the application, so we can have various instances of it, but it just enables us to have consistent states. So one view doesn't have like loading and success and failure, and the other view only has loading and something else. And so
Mm.
we can ensure, like a lot of times too, what will happen is developers will have multiple functions that can update the same data. And so what they'll do is they might update the data here and update the data here, and then change the different states. A big thing with like Swift UI, for instance, is like if you want to update the error state. When I have an error on the API, I want to update a published variable, and then I want to respond to that change on the view whenever I have an error. And so you might have various different positions in your code where you're updating that manager. And as the class grows, you can have inconsistencies across your states because I'm having three different functions update the state of the applications and the error messages or whatever. Versus if I have a state manager, I can consistently control that state from one source of truth and update that at one time versus having multiple different locations, multiple different variables that I'm updating to respond to different types of errors or situations with the data.
Yes, thank you for clarifying. Interesting. So I think the thing that confused me is that you placed it near the DI injection, and basically DI is sort of like a global thing that we use for like our dependencies. So I thought the state manager is also like some singleton, like in Redux, and you use just one for everybody. But since you're using like multiple state managers, maybe we can make sort of like two of them for the chat list view model and chat thread
Yeah,
view model.
absolutely.
And also,
Yeah.
it would be nice to see who owns it. So basically, if this is an object, so does it mean that the view model has a dependency on a state manager? So the view
Yeah. So
model
it would,
owns it.
yeah, the view model owns it. It's not necessarily a dependency. It's just the view model is going to
Hmm.
contain the reference to the state manager that the view will use.
Okay,
So
interesting.
think of the state manager as I guess the best way to put it, almost like a protocol. It's almost like you're defining the way that you want your view to respond to states and
Hmm.
ensuring that that state is only managed from one consistent source.
Okay, got it. Okay. Hmm.
So that should be, yeah, that's pretty much it for the high level design. I think that covers most of, yeah, if not all the scenarios for our functional requirements. Let me know specifically which section let me dive into as far as the flow for, if you need me to go to end as far as the flow for chats in our various different scenarios or things of that nature, I can do
Um,
that.
Yeah, it would be nice to see the data flow for chats, for chat threads. And
Mhm.
yeah, so what happens with the data, how it flows. Yeah. And after
Yeah,
that,
absolutely.
an interface for the coordinator. It would be interesting to see how it works.
Yeah, absolutely. So what we'll do is I'll walk through the data flow and then
Hmm.
I'll also draw out a quick little interface for the coordinator as well when we get there.
Hmm.
So first things first, the chat thread view, the initial state, we'll start with the state where we don't have any data. We're just loading the application or, and we want to fetch the initial list of data. The coordinator is going to obviously attempt to check if we have any data inside of our local database through our repo. So it's going to make a request inside of our coordinator to see, do we have any data from our Realm DB? And if we do, we want to show that to the user immediately, obviously, for an enhanced user experience. As it's doing that fetch for data, we are returning that really quickly, obviously, to our chat view. We'll update our state manager as success, and then we want to, obviously respond to those changes on the thread view and show those chats. But then what's going to happen in the background as well is we're going to make a request to our API client. We're going to do a GET request and essentially want to make sure that we haven't missed any data. So we want to get all of the data that is relevant to our chat within reason of our constraints of our page size of like 50 chats or whatever we determine. That's going to be returned to the chat view model as well. And the whole idea behind this coordinator API client thread is we're going to use Combine, like I mentioned previously. And so we're going to be able to emit a stream of data through our various different data sources to our chat thread, and it's going to update our view model immediately. So as we're subscribing to these different services and getting updates from the values, we're going to pass those through our publisher to our view model, which is going to subscribe to those changes and listen so we can receive those updates from the various different sources in real time. And the good news about the coordinator and the way we do the Combine abstraction is that the view model doesn't need to know any of the information about where the thread coordinator is getting its data from. We'll abstract it out to a publisher known as any publisher, which is just, is like it says, it's any publisher. And so the view model doesn't have to worry about where the data is coming from, how it's getting the data. It just has to worry worry about. I'm getting this type of data and how to respond to it. And the coordinator is going to manage the sources that it's getting that data from. So once we receive the initial set of chats from that GET request, we'll return those to the view model to update accordingly. And then from there, we want to initiate or establish a connection with our WebSocket through our coordinator. So the coordinator is going to establish a connection to our WebSocket, and we'll receive a stream of events through our coordinator to our view model. Now, I would separate those functions, like the API client and the repository, fetching that initial static data from REST, and then have a separate function for establishing the WebSocket connection, just so we have two different subscribers to receive data on, and it'll keep it cleaner for our overall architecture. So that will be the initial case. The other case would be where we want to just fetch new chats, obviously, which is going to function very similarly, except for the fact that our chat is going to actually return data from the local database and show that to the user first while we're fetching that new data. And then lastly, let's see, the WebSocket. Yeah, I think I already dove into how that one would work. So that's kind of high level how the data would flow from our chat thread view model to our, to our clients and services back to our view model. The only other thing I didn't touch on would be the file storage. So if we want to retrieve a specific message or image, we would use the coordinator as a separate function to fetch those images from a URL. So essentially what we do in the coordinators, we would say, hey, do we have data for this URL in our local storage or our database somewhere? If yes, we return that. Otherwise, we want to make an API request, get the data, save it in our storage, and then return it to the view model.
Quick question. What about
Sure.
the cache eviction policy for images?
The cache what?
A cache eviction policy. Basically, do we want to store them forever, or do we want to delete them at some point in the future?
Yeah, so I think for my design purposes, I didn't consider that, which we definitely should. I would probably institute maybe like a TTL policy where each file is saved with a certain time to live configured by the
Mm-hmm.
server. So after XYZ period of time, we can invalidate our cache for that specific image, and then refresh a new one. The good news about our data, like at least when you're sending files and things of that nature, you don't want to overwrite files that have been sent through chat because those are constant. If I have an image sent from my grandma, a year ago, that image is never going to change and it never should change. I think that should be cached indefinitely. But when it comes to things like our profile pictures, those things can change as well. And those would be the data that changes frequently. But I think our files should probably remain in place indefinitely, and we should put a TTL policy on our profile images and things of that nature.
Wait, why don't you want to delete a message to your grandma? Let's say it was like long before in a chat thread. Do you really need to store it? Because you can download it from the server if you need it.
Yeah, I mean, you could go both ways. I mean, it kind of, I mean, you have to do probably honestly with this specific scenario, you might want to do a user study and see how users are using the application. Me,
Yeah, makes
me,
sense.
me, me personally, I like having my images on my device because in the event that something happens, it's there. It's not in some cloud file somewhere. It's not stored in a distance. It's on my actual device. But you might have users where memory is a constraint. They might have a smaller iPhone where they don't want to keep every single message for an indefinite period of time. So I would almost give that kind of control to the user as far as, do you want to keep messages for, it's similar to how iMessage would function. You have the option to say, I only want to keep messages for 30 days. Other than that, I want to remove them from my phone and just keep them in the cloud. So I'd probably say we
Yeah.
want to configure that from server side or from the user side and let them determine how long they want to keep their data for, most likely.
Yeah, makes sense. All right. What about so for images, do you need sort of like any additional caching? So do we want to always go to the file storage to get an image that may frequently show, like an avatar or something like that? Because accessing files can be like slow. Maybe we need additional cache.
Yeah, I mean, it kind of depend for like, I mean, you could use something along the lines of like NS cache potentially, but the
Mm-hmm.
only problem with NS cache, obviously, it's going to invalidate the cache frequently, and so you're going to end up having to make requests relatively. We could do like a multi-level system almost, where we could have a NS cache for quick read and writes, or not quick read and writes, quick retrieval for like profile images as we're scrolling through like a feed, for instance. And then that the system will manage the invalidation of that cache on its own, depending on memory constraints and when it needs it. And then we can rely on the file storage as kind of like a backup when we don't have something quickly in the NS cache. We can retrieve it pretty fast from the file storage secondary. And then obviously, if we don't have the file in our file storage, we can retrieve it from the API client as well. So,
All
but yeah,
right.
that's something to
Yeah.
consider for sure.
Yeah, makes sense. Yeah, I think we forgot about the interface for the chat thread coordinator,
Yeah, absolutely.
right?
I'll draw out some quick interface over here on the right just to kind of give an idea of what it would look like. So I'd have a, let's just say we'll do a protocol. We'll just do the class chat thread coordinator. We have chat and coordinator, and this is going to be obviously a, let's see, yeah, that's it. That's going to be there. And we have a couple functions here. We'd obviously define our references to our various different clients. So we have a reference to our WebSocket, our repository, and our API client. So I would just say, let API client equal, our API client reference. If we use a singleton for that, we can reference it here. Client, we'd have our reference to our repository, let repo equal repos. We'll have a what's called chat list repo.
I'm mostly interested in the public interface, basically the methods that you call on the
Oh, got it.
coordinator. Yeah, so
Yeah,
we don't need
absolutely.
this
That's fine. Yeah, perfect. I'll leave these here for now. But yeah, we'll do what I
yeah.
would do is I'd have a generic function, obviously for func. We'll say fetch chats, right? And so inside of this function, this is where we would do the differentiation between the different methods. So we would do obviously we would want to return this function is going to return any publisher with a chat list and or an error. And we want to essentially return a publisher dependent upon the data source we retrieve from. So we obviously want to publish to that publisher first the retrieval from our local storage. And then so we have a function here that would be, retrieve from local storage first. And then we'd have a secondary function after we retrieve from local storage. We want to retrieve updates from API and merge with local storage.
All
And then we'd
right.
have the
Yeah.
last function. That would be for retrieving the chats. And then we'd have another function to subscribe to our WebSocket update. So func subscribe to our WebSocket. And then this will be the same thing, similar to the before. We have a publisher that
Interesting.
would return a real-time update.
So you want to place the method subscribe to WebSocket into the coordinator. So that means that the view model would call that method, right?
Correct. Yeah, the view model would call subscribe to WebSocket and then
So
hang
the
on to
view
the
model
subscription.
would know that WebSockets exist. Do we want the UI layer to know that WebSockets exist? Let's say in the future we move from WebSockets to long polling for some stupid reason, I don't know. So in that case, we would need to change the view model, but probably we want to abstract from that and not to expose it here. Do you think it's possible, or do we need to explicitly?
I think when you have an application that has real-time updates, you have to expose some type of real-time updates. If you were to switch to like real-time or long polling or short polling or something, it would be a completely different flow. So I think when it comes to like, you don't have to necessarily say WebSocket. You could change the functional signature to subscribe to live updates or something. At the end of the day, the thing that we're doing is if we wanted to say subscribe to like live updates.
I think that would be better because that would
to live. The good news is that this publisher is going to return a consistent type. So we know that this is going to be a chat, chat list and then error. So whether or not we use long polling, we use short polling, or we use a WebSocket, this live updates is going to subscribe to a stream of data in some form. So we could probably get away with using a different name, but for now, I think that's probably what we have to do is have a separate function signature to subscribe to those real-time updates in real chats.
All right, yeah, makes sense. Thanks for clarifying. Yeah. I think we have not covered the offline support for sending. So do we need any like additional maybe entities on our high-level design for that? You mentioned the queue.
Yeah, what I would probably do is, so the queue is going to be relative to, I would say we have a flag in our Realm database. So essentially what we'd want to do is we want to query our Realm database for any chats that haven't been sent yet. So that's going to be our flag of whether or not the chats have been sent. So we don't need a separate necessarily queue, literally, in that sense, to send the chats. We're going to basically batch together all of the unsent messages. And then we'd probably want some type of background manager or offline manager that we would use independently. That would essentially happen whenever we resume from a background thread or something similar, or we open the application, do a query, see if we have any updates that need to be pushed, and then handle that connection to the make that request to the through the thread coordinator for those changes.
Yeah, makes sense.
Or to push those changes. So.
Could you please add it to the diagram? And
Yeah,
I
for
guess
sure.
that object would need a connection to the API client. That would ruin your beautiful arrows. But
well, I think
still.
what we could do, honestly, though, is for those updates, I think we could probably have our background thread go through the chat coordinator to go to the API client. So everything from syncing the, we're already gonna have a functionality in there to send a message. So what we'll do is just have a background thread manager here. We'll have a offline sync manager. And essentially, this is just going to do all of the updates. It's going to do the query to our repo. We're going to do a query here to see if we have any updates that need to be made. And then if we do, we're going to use the chat coordinator to submit those updates accordingly if we have any.
Okay, yeah, makes sense. What about if WebSockets drop? Do we have any like WebSocket reconnection mechanism? How this would happen?
Yeah, so I don't, not in this design, obviously. I think that would be something we'd want to potentially handle through the coordinator. If we like drop a connection or something similar, handle the retry logic there. We could probably abstract out a WebSocket manager maybe that would handle the connections if there was any kind of disruption or something along those lines. We obviously want to use the WebSocket, the chat thread coordinator to end and establish connections dependent upon whether we enter the background or not. We'll end that connection whenever the user enters into the background, and then resume it when we resume from the background. And we can handle that in the view lifecycle. So yeah, maybe we could potentially add in a manager that would handle the reconnection logic. But I think for the most part, the coordinator is going to handle the majority of that load for the most part.
Yeah, makes sense. Going back to our discussion about the sending messages via REST versus sending messages via WebSockets. So what approach do you actually want to use? Or do you want to use both of them? How would you send messages?
Yeah, I would probably use both. I mean, what we would do is we'd use both, and we'd have a fallback. So essentially, what would happen is we would try to send a message to the WebSocket, and we have that connection. In the event, like I said, we do an offline sync manager. We have messages that haven't been sent, or messages that even may have failed, or didn't get marked with that sent status. We could use the post endpoint to send that message accordingly from the post request. And essentially, the good news is that since we have a timestamp of when we sent that message, the server will be able to dynamically update, the messages in that correct order, because we're caching obviously the time that the message was sent at, or the time that the message was actually sent. So that should handle that. But yeah, I think that would be the best method would just be to send it to the WebSocket. And then if we have any situation where it fails or connection isn't intact, we store that in our local realm database and have our offline sync manager clean up the discrepancies.
Yeah, makes sense. All right, we talked a lot about the network. Let's briefly talk about the UI. So my first question is how would you implement the navigation between screens? And how would you pass the data? Let's say a chat list ID or something like that.
Yeah, so for
chat
the Swift UI
ID.
implementation, what I would probably do is for the chat list will be implemented as like a navigation stack with a dynamic list. You could use a Swift UI list or even a lazy V stack. And then what we would do is whenever we want to open an individual chat, we'll push that chat view onto the navigation stack, but we're going to instantiate it with our chat object. So we have references to the chat ID, so we can make that request. And essentially what's going to happen is as we instantiate that new chat object, we're going to do that process of going to our view model, going to the chat list coordinator, checking for any chats related to that chat ID, and then returning them in our whole network, paradigm or our whole network flow that I mentioned previously. So the high level answer is I'd use a navigation stack with the ability to instantiate a chat view with a chat object, and using that to pull all of our data from our local databases and network and things of that nature.
Yeah, makes sense. Makes sense. All right. Last question for you. What about emoji reactions? So how would you implement them?
Yeah, absolutely. If I was gonna expand to like an emoji, what I'd probably do is over here in our message object, I would
Hmm.
have to probably add reactions or something similar, where we could store the Unicode values for the specific reaction. So I'd come here and I would probably say underneath attachments, we would say reactions or reaction. Most of the time we're limited to one unless we're in like a group chat or something. So I'll say reaction, and we would just store here the Um, Unicode values for each reaction. And then we would basically do a check on our view whenever we're instantiating our view models for each cell. If a, or not our chat list, our chat, we would instantiate our view model. And basically, if there's a reaction, we'd have a certain spot on the UI for it and display the Unicode accordingly to the design mocks or product specs. Once we have that Unicode, we can kind of place it anywhere dependent upon that. And then for like actually doing them, and sending the Unicode, we probably have to have another endpoint or not necessarily an endpoint. We could have it as part of the message object. So when we're sending it through our WebSocket or our post endpoint, we'll have those Unicodes to allow the other user's device to respond to that data.
All right. Yeah. Sounds good. Let me spend a few minutes preparing a feedback for you.
Sure.
All right. Let me share my feedback, which I've divided into 4 rating pillars. So the first one is problem breakdown. You did 4 out of 5, which means solid performance. You asked reasonable questions to break down the problem. I really like that. You had a solid plan of attack, step by step what to do. Also, you demonstrated leadership throughout the interview, which is a really important part of this. Next, system architecture, 4 out of 5. So you proposed a working solution with UX in mind, which is cool, obviously. I think it's nice that you suggested pagination for reading chat lists. The only my concern is that you did not handle inconsistent paging when new messages arrive. Other than that, you recommended using post for sending messages instead of just relying on WebSockets, which is not probably the best solution possible. I like that you also suggested introducing an attachment object for attachments. You generally followed a layered architectural approach where you had like a presentational layer with view and view model, and you had a domain layer with your coordinator and a data layer with a network client, a repository, etc. So in terms of technical proficiency, you did really well as well. You used the modern iOS tech stack, Swift UI combined, and designed a clean and intuitive interface. Next, communication, 4 out of 5. You responded well to my questions and to my feedback, which is also really important. You explained ideas clearly and logically and effectively discussed trade-offs. It's a really important part to provide multiple solutions for a problem and then discuss pros and cons of it. So generally, you did really well. Thank you for your time.
Awesome. Thank you so much for that feedback. Yeah.
All right, see you.